researcher's data. Is there more? Oh, you sent more pictures. 8B.
Yeah, there should be an 8B.
Okay. So that's probably, let's see here, complete the top 2 rows of the researcher's data. So they said that out of all the males, there are 2 that like the taste and 2 that do not. Okay, let me snip in this other picture. They I don't know why they ever need to do this, but you're just trying to like figure out see if I can just overlap here. Yeah. So it's like you know that there's 2 males that like it. So there's your males, and then there's the 2 of them that like it. Does not like, sorry. So I'm trying to get this. Okay, let's do it this way. There are trying to figure out
It's either
this.
gonna be like in my other 2 attempts, it was all zeros, but there was also one where it could be all ones.
Mm-hmm.
I don't know.
Okay, so see how likes the taste of the Vegemite. There's 4 and 2, so 1 2 3 4 1 2. So these definitely are does not like,
Okay.
for sure. And then do we have the 2 males that like it? I'm sorry, do we have the 4 males that like it? So males are zeros. Yes. So males are zeros, and we have the 4 that like it. So we have that taken care of. Do we have the 2 females that like it? So we're looking for 1 1 1 1. There we go. There. Okay. So that's these down here. I know you're just looking for the answer. So what are we missing here? We're missing the 2 females that do not like it. Yeah. So it looks like it's all zeros for that one. All right, that's like part of it. The phi correlation is the appropriate correlation for this experiment because I have no
It
idea.
says neither variable is dichotomous. Both variables are dichotomous. Only one variable is dichotomous.
Well, both variables are dichotomous because it's either male, female, like, dislike. But I guess I would need to just confirm that the phi is used for dichotomous variables. I believe it is.
Yeah, it's been both for all the other.
Yeah, it is. It is.
Okay. And then the answer choices it gives me are negative 0.07, negative 0.17, negative 0.14, and 0.83 for the correlation.
I would have to do the calculation to tell you, and I can do that. I just need to look that up. So it's okay. So let me look that up. Unless you've got the.
I don't even have that formula. I don't know what that
Okay.
is.
So I'll just search Chegg for this question. At least one of them will have like how to do the calculation.
Okay.
AD minus BC. Okay, so the AD 2 3. Okay, so they're considering this to be A, and the formula for the phi coefficient is this well, you don't care, but it's AD minus BC over the square root of A plus B, A plus C, B plus D. Yeah, there's B plus C. I guess that's not in there. C plus D, C plus D, B plus D. All right.
Okay.
So we got you multiply diagonally, so it's 4 minus 8, so it's definitely negative over square root of a plus b. That's 6. A plus c, 4. C plus d is 4. B plus d is 6. Okay, I'm sorry, these are all multiplied. All right, so that's on the bottom. What is that? 6 and so we have 6 and 4, 24. So it's negative 4 over 24. So negative, you said negative 0.07 was one of them.
Let me see.
Negative
Yeah.
0.17.
Negative 0.07, negative 0.17.
Yeah, 0.17. That's what this equals.
Okay. Yeah, that works.
Is that everything for 8?
Yeah.
Okay, so we're on to 11.
Yes.
Make a scatter plot of data shown here. Okay. Do we need to update the graph on this one, or is it just for help?
I think, yeah, we do have to update it.
Zero sum of distance. Okay, let me look up what this question actually wants. I think you have to put the triangles on each point to show like how far away it is from the mean, but I'm not sure. So let me look and hopefully get it.
Okay.
I'm looking at a picture here. This one's not super helpful. Still don't know where they're getting that from. Sum of the vertical distances between the sample points and the orange line is the sum of the square of the vertical. Orange line is. Okay. All right. Maybe. Okay. Let's snip this in. See if we can help a little more here. All right, so they give you an equation of this. They tell you that y equals minus 2x plus 10.
Yeah.
And these are your x values. So we're just gonna estimate it here, get the estimate the y hat here. So we're gonna put this x value in. So it's are they giving you, are these data points? They must be giving you these data points. Okay, maybe that's what all right. So the when you do 8 credit hours, although that seems to be the y. Oh boy. Yeah, that's okay. So your x is, I guess your x is 1, 2, 3, and 4. Okay, this is your x. Now I see it. That's your x. This is your y. We're going to use these numbers 1, 2, 3, and 4 in this equation to get your predicted y. So it's minus 2 times 1 plus 10. That gives you 8. Minus 2 times 6. That's I'm sorry. Minus 2 times 2 is 4. Minus 2 times 2 is negative 4 plus 10 is 6. Okay. And then three gives you a predicted value of 4. And then this gives you a predicted value of 2. So none of that probably makes any sense until I grab the picture, and I think maybe we can do it now. So the blue circles, these are the this is the actual data. And then this line right here is the predicted. Okay, so like, see how those first 2 points are right on it?
Yeah.
This one right here is 1 away. Like it's +1. This one right here is +3 away.
Yeah.
Okay, so the sum of the vertical distances between the sample points and the orange line, there should be an option for 4 there.
Okay. Yes, there is.
Okay, and then the sum of the squareds, you have to square those both. Okay, so that's 1 squared plus 3 squared is 1 plus 9, which is 10. Okay, so we got that. Now, this next thing is still kind of unclear to me. Maybe you're able to get those values already through looking at some resources on the web. They get a point on the graph, like what I'm seeing is this green line is being drawn through a point, like they're updating, and that's the surprise. I don't know where to tell you this point goes, because I don't actually understand how they're finding it. they're getting a point somewhere, like maybe here, and then they're drawing a line through it. I just need a few more minutes to look to give you an answer, or we can move on, but I need more information here to be able to help you with that.
Okay, I'll try to look too.
It could be as simple as a line that is a little bit away. I can't. Oh, I see. They want you to find MX and MY, and that's how they're doing it. Okay, so you're supposed to find this thing called MX, and it's adding up all the X values, 1 plus 2 plus 3 plus 4, and dividing it by 4, which is 2.5. And then MY is all the Y values. So that's the 8 plus 8 plus, what do we have here? I'm sorry, 8 plus 6. 8 plus 6 plus 5 plus 5 divided by 4. That's these values here. So that's 14, 24, that's 6. So this is an ordered pair, 2.5 comma 6. And so what you do is you get the line through that point. So you want to create a point on your graph, 2.5 comma 6 right there. Okay, and then it has to have a slope of -2, because that's the slope of this one right here. So you go down 2 over 1. So it's gonna have like it's gonna hit like there and there, like right in between. Hopefully that's enough to go draw it. So your green one's gonna go through here like this.
Okay. And then, so the green only gives me 2 points. So should it be where you put those triangles?
It does grade the endpoints, doesn't it, on these things? I don't feel great about doing that. I'm seeing one where, yeah, the endpoints are like there, like all the way at the top and all the way at the bottom. I'm seeing one kind of like that.
Okay. So it's gonna be like,
If you want, you can send me a snip of what you've got and I can look at it.
okay.
Up to you.
So it's not gonna be like 110,
No,
the top point.
no,
It's
it's in the middle. It's the
gonna be like
0.5.
19.5.
Can you go up to 10?
Yeah.
Yeah, go up to 10. It's 0.510.
Okay, okay. And then like 5, 1 at the bottom.
Yes, that will do it.
And then the plus sign, do you see the black plus sign? Do you
Oh,
know?
that plus goes right there. That's at the 2.5 comma 6.
2.5 comma 6.
Yes,
Okay.
yes.
All right, got it. And then
Is there
now,
more?
yeah,
Yeah, there
there's
is. There
a
is. The line you just plotted, I don't know what the drop downs are, but it
passes.
passes through. Yeah,
Yeah, passes or does not pass.
passes.
Okay, and then the next one gives me 0, 1, 10, and 6 for the answer.
Oh, I see what they're doing here. The sum of the squared vertical distances between the line that you just plotted, sum of the line between the sample points and the line just plotted is, what are the options for that?
0, 1, 10, and 6.
So it's the distance. So it's like 1, 2, 0, and then 2 again. So it's like 1 squared plus 1 squared plus 2 squared. So that looks like 6. Is 6 an option?
Yeah.
Okay, good. And the line you plotted that has a sum of the distances equal to 0 is the third bubble there, because it's
Okay.
like down 1, up 2, so they cancel out.
Okay.
Suppose you fit the regression line to the 4 sample points in the graph, and the basis of your work so far being as specific as you can be, you know that the total squared error is, what are the options there?
Less than or equal to 6, 0, between 6 and 10, less than or equal to 10.
Oh God, it's like it's 6, so it's like equal to 6. Let me go find another one to see what these say. All right. Is 6 an option, or is there more? Is it a range? Is it range?
There's less than or equal to 6, and then there's between 6 and 10.
So let's go less than or equal to 6 on that.
Okay.
I think it's 6, but let's go with that.
Yeah, that worked.
Great.
Okay, so then there's another problem in there that I just had a question about.
Okay.
It's the one, there should be a picture of like 5 different correlation graphs.
Okay.
And I just was confused because I don't really know how to figure out like how to match the R to the graph.
Okay. Yeah, let me grab those and see if I can help here with that. Oh, where is it? Because I'm not seeing it. Is
Oh,
it
is it?
in? Yeah. If can you resend it to me?
Yeah. Okay, I just sent it.
Checking. There it is. Okay. Get that screenshot in there. Okay, the following are scatter plots, including the regression. Okay, so your question is like how you figure out like which one goes with which number kind of thing.
Yes.
Okay, so it's a little bit of like process of elimination. So the like because the trend line here is horizontal, this is always going to be R equal to 0.
Okay.
The trend line helps you with that one. So as we talked about, if it goes up, that means that R is greater than 0. And if it goes down, we know that R is less than 0. So that's like your first indicator, you know, whether it's positive or negative. So then like you're maybe comparing between like 0.66 and 0.82.
Yeah.
So you're looking at like, let me see if I can just snip in just the ones that we want to explain. Because when there's so much going on, it's hard to focus what we're trying to do here. So there's that one. And then there is this one also that's going up and to the right. And then the question is like, it's basically comparisons, like which one has the tighter fit of the data? Like,
Oh, it's okay. So it's less about the line and more about the data.
there's nothing to do with the line other than up or down. Yeah. So it's how well
Oh,
does this fit? This fits like good, great. I
okay.
don't know, great. So that's why this one's 0.82. This
Okay.
one's not as good,
Okay.
better than others. That's why it's 0.66. And then you do the same thing for so it's like how close are the data points to the line?
Okay.
And that's
So
how you decide.
okay. I was basing it off the line. That's why. Okay, we can move on.
All right. Where do you want to go from here?
Let's do chapter 12, part 1 and 2, and then go see if we have more time.
Okay, chapter 12. All right, part 1. ANOVA. We did a homework on this a while back. No. Okay. I guess we'll just go through this one question at a time. Okay, what is the difference between the test-wise alpha level and the experiment-wise alpha level? I'm just going to look up here in the notes and see if there is an explanation or I can provide my own. I don't see one. So an ANOVA is used when you're comparing more than two groups. So like, let's just say you're comparing group A, B, and C. The test-wise alpha level is when you compare like A with B and B with C, and then A with C. And when you have all these alpha levels for each of them, you have to add them up. And see how that grows pretty quickly?
Yeah.
When you do this like experiment wise, or maybe I got this backwards, because I don't know why they're saying test wise versus experiment wise. When you do an ANOVA, instead of doing the groups, the ANOVA, you can just cut straight through all that and use the 0.05 alpha level. So in short, like rather than comparing all the groups where you have to add up the alphas, it's better to do the ANOVA because it's a lower alpha level.
ANOVA is always 0.05.
No, it could be anything. It could be 0.01, it could be 0.1. But when you do an ANOVA is comparing more than two groups. And if you didn't have an ANOVA, you would have to compare each group to each other. You know, A with B, B with C, A with C. You have to compare the groups, and the alpha levels start adding up for that. But the ANOVA cuts through that, and it just uses the alpha level that you're given.
Okay. I see that now.
Okay. If that is not clear or doesn't, like maybe there's some notes on a slide that actually says in one sentence what I was trying to convey.
No, I think that makes sense.
Okay. All right. So the next question here, it's basically like being able to, the instructor really is, they're going to ask you a question like the ANOVA is, or I'm sorry, the FF is, and you're looking for, it's a sentence with the following in it, this formula in it. The variance between treatments. So like what I'm trying to show you here is let's say this is group A, this is group B, and this is group C. The variance between treatments, the between is here, between and between. The within is inside here. Within, within, within.
Okay.
So what you're hoping for is that between the groups, there's a lot going on compared to what's happening inside the groups. And your instructor wants the formula, but it's a ratio. It's a ratio of the variance between the groups, which is, you know, kind of like, it's like the macro view
Okay.
versus over the micro view. The macro is like, how do these compare to each other? It's like, you know, the US, China, and Russia. And the micro is like, well, what's going on inside the country itself?
Yeah.
I mean, that's essentially what this is here.
Okay.
Okay, can I move on to 3?
Yeah.
Right. Okay, if there's no systematic treatment effect, then what is the expected value on average for the F ratio in ANOVA? So there's really two F ratios that you care about. Either it's equal to 1, which is bad. That means there's like nothing happened, you know, no significance, or it's equal to a large number, and that means that there is a difference. So F is the between over the within. So it equals 1 when there's not much difference between the groups as within the groups.
Okay.
And that's like not what you want, but that you know, that could happen. If you get a large number, because between the groups, between A, B, and C, comparing these groups there's a lot of variation, but within the group, within like one group or the other, there's not much going on. Then F becomes very large. So now we can actually answer this question. If there is no systematic treatment effect, and what this means is that between equals within, then what values are expected on average for the F ratio? Well, 1, because no systematic treatment effect means that all the groups are roughly the same. And if all the groups are the same, your F ratio is 1.
Okay. We can move on.
Yep. So 4 is kind of a related question. If there was a systematic treatment effect, then F would be very large. Okay, and that's what this is asking here. It's saying, well, what does it mean if you get a large F? It means because f is between over within, it means that the between is a lot larger than the within. And that means that there is a systematic effect. Like the treatments do something different. The groups are different between each other.
Okay.
All right, number 5.
Yeah.
Okay, so how would you evaluate whether to reject or fail to reject the null hypothesis based on the F ratio? So the F curve is, this is always a right-tailed test. So your curve, your distribution curve looks like this. Okay, and there's a critical value right here. That's the critical value. And if your F is here, then you fail to reject. But if your F is here, you reject.
Okay.
So if your F, the one you calculated, is greater than your critical F, then you reject. That was this over here. If your F is less than the critical F, then you fail to reject.
Okay.
That's all there is to say about that.
We can move on to the second part.
All right. So part 2.
Actually, I don't know if there's any practice problems.
Yeah, you're not going to get any. I don't think you're going to get any actual ANOVA calculation problems. Maybe you'll get a table and have to fill it in, but you're not going to be expected to do it. There are no practice problems for part 2.
Okay, so then we can go to chapter 7.
7. Okay. All right. So practice problem number 1. All right. What is the probability of obtaining a sample mean greater than m equals 60 for a random sample of n equals 16 scores selected from a normal population with a mean mu 65 and a standard deviation of sigma 20? So whenever sigma is given, sigma is the Greek letter. You know that this is a z. This goes along with z. Now it tells you down here, but sigmas go with z. If they give you s goes with t. So maybe we make a little table here. Sigma goes with z, s goes with t. Okay, so they want you to find they want you to find all 3 things that help you lead you to the actual question. Like that's the thing that maybe is on your test, but you got to do these individual things here. So the standard error is sigma, your sigma, which is 20, over the square root of n, which is 16. Are you allowed a calculator on this exam?
Yes.
Okay, because the numbers so far have been such that you could do it without, a calculator, but this ends up being 5. Your z-score formula is not given. It's m minus mu over sigma m. So your m is 60 minus mu 65. That's that right there, over sigma m, which is 5. So this ends up equaling -1. And you probably remember doing this. Here's your normal curve. Here's 0. -1 is over here. Since we want the probability that m is greater than 60, we want all of this region over here.
Okay. We can go to practice 2.
Okay, next problem there. Okay, so you'd have to look that up or do something else with that. So practice 2, problem 2, we can do that. All right, what are the boundaries for the middle 50% of all possible random samples of n equals 25 scores from a normal population, mu equals 80, and sigma equals 10? So what your instructor is asking for, here's your bell curve again. Here's 0. So there's some number over here and some number over here, and they're the same. So that the area in here is 50%. So if this is 50%, that means that there's 25% over here and 25% over here. Do you remember? Does that make sense? Because the whole thing's 100%.
Yeah.
Okay, so you need the z value right there and you need the z value right there. Okay, but they're the same, like one's negative of the other. So if you remember in your calculator, there's like an inverse norm or an inverse z for that. And you want you want 0.25 because that's this one over here.
Okay.
And if you got a table, we could look that up, but
I do have a table. I have a table, but I don't know how to do it on the calculator. I kind of want to learn that.
Okay, so do you have your TI whatever?
Yeah. Yes.
Okay. So let's see here. Let me grab mine and I'll try to show you. I'll have to switch screens. Learning students. Okay, so let me switch screens. All right, so if you're seeing my screen, you see a TI 80 something, 83 here.
Yeah.
You're going to go to second distribution, which is under vars, above vars there.
Okay.
And you want inverse norm. Okay, now if you've got a TI 84, it probably gives you like something to fill in here.
Yeah.
You keep your mean and standard deviation of 0, 0 and 1 as is, but it wants the left tail value, which is 0.25.
The area.
Yes, the area is 0.25. That's the area in the left tail. And then I think I have to put these in. So let me hit enter. Yeah. So fill those in, click on paste. It should look like this and you should get this value here.
Yes, I got that.
Okay, so that's how you do it.
Z-score?
I'm sorry?
That's the z-score?
That's the z-score. So let me go back to sharing the other screen so we can, and I'll come back to this if I need to. Nope, that one. Okay. So now we got these two values, okay? And there's this, if you recall, z is equal to x minus mu over sigma. Okay, so in this case, we want the x value. And if you solve for x, which you probably were given this formula, x equals z sigma plus mu. And you might be thinking, what does that mean to me? Well, you have all those values. You have the z value. You have negative 0.67. Your sigma is given in the problem. Your sigma is 10 and your mu is 80. Okay, so we're gonna get that number there first. So that times 10 plus 80 gives you a 73.2551. And then if you use the other z value, 0.67 times 10 plus 80, you get something similar, get the bigger value.
Okay.
You get 86.7449. Okay, and those are the two values that the instructor is looking for. Now your calculator can actually do these directly. Okay, so let me go back to the calculator and show you that. You know, you can either check or do it both ways in the exam if you got time. But if you go back to second distribution, inverse norm. Okay, so this time instead of putting 0 for the mean in your question here is 80. So you put 80 instead of 0. And you're entering that in there. And then your mean is 10. And then when you hit enter, you get that 73 number that I just showed you. Wrote down before. Now the other number, this is where it gets a little bit dicey, a little bit uncomfortable, is it's 0.75 now because it's the other side.
Okay.
So wrong number there, but you'll see you get the 86.7449 like I wrote down there. So you can definitely do it both ways. I would keep it as 0 and 1 just in case you get a bunch of problems like this. That way you just multiplying. And it because this could screw you up if you don't remember to change 80 and 10 back to 0 and 1.
Okay, I just changed it.
Good. Okay, so that takes care of that question on that particular thing here.
Okay. We can go to maybe chapter 9.
Okay, putting it up now. Okay, chapter 9 is T stuff. It's basically the same as Z, except you got this degrees of freedom stuff. You got a small thing on effect size. All right, let's see if we get down to some problems. Problem 2, where's problem 1?
I'm not seeing a problem 1 either.
Yeah, I don't see it either. So we'll just go to problem 2. Okay, so all right, problem 2. 144 job seekers, that's N. Okay, worked more than 30 hours, an average of 6.9 months last year with a standard deviation of 2.5. So that's S equals 2.5. The typical job seeker works 6.4 months. So they're that's talking about the mean. That's your mu. That's the 6.4, and your X bar is 6.9. Okay, so your Cohen's D, which it's strange that they're asking that for that here, but nevertheless, your Cohen's D is D equals M minus mu over S. Your M is the X bar. What I'm calling X bar is your M. So that's 6.9 minus 6.4 over 2.5.
Okay.
And if you're going to throw this in calculator, make sure the numerator is there. So the next, can you give me that value? Because there's a kind of a related thing you might see on your test.
0.2.
0.2. Okay, so it's like from 0 to 0.2 is, actually I don't know how this is. We'll just say it's 0 to 0.2. Is considered small. 0.2 to 0.5 is medium. 0.5 to 8 is large. It could be 8 and above, could be 0.2. I don't know. This isn't actually a very good chart, but you'd say that it has a small effect size.
That's the chart. That's the same chart she gave us.
Yeah. So, all right. Now they give you the test statistic, the T statistic here. The T statistic is found. It is M minus mu over S divided by the square root of N. So it's the 6.9 minus the 6.4 over 2.5 divided by the square root of 144. Make sure you have all that in parentheses, but that should equal 2.38 when you get that in your calculator.
Yeah, I got that.
Okay, so this R squared is such a horrible formula. So R squared is T squared over T squared plus degrees of freedom. Okay, so you have to take that t value you just found, 2.38, square it over 2.38, square it plus degrees of freedom. Degrees of freedom for this is n minus 1. So it's 144 minus 1.
Okay, I got 144.
For
The answer.
you got this all has to be in parentheses. Like whenever you're dividing, when you go to your calculators, 2.38 squared slash parentheses 2.38 squared plus 143. It's probably how I would enter it. It should be pretty small.
Oh yeah, it's 0.038.
Yeah, very, very, very small.
Okay.
Any short questions I can answer?
I think that's it. I mean, I need like a 10. The points of the test are there's only 20 points. And I need like a 10 out of 20 to keep an A. So I think I'll be fine.
I think you will be too.
But there's a lot of formulas. So
Yeah. All right. Well, thank you so much for scheduling, and hope you do great on your exam. And if I can ever help again, let me know. Text me and
okay.
ask or whatever. So have a
Okay.
great time off this semester, middle of the semester here.
Thank you, Matthew.
You're welcome. Have a good night. Bye now.
Mm.